All right, here we are. What is this? Day 9? No, day 20. We did day 19 yesterday, which was figuring out some satellites communication errors, I suppose. Message validation. So we can figure out if there's a sea monster, which may be this squiggly guy right here. Yeah, yesterday's was interesting. It seemed like I kind of cheated using the regex method. I think what that question called for is how to check like a branching condition without actually having to branch out. I think regex does the same thing. You have regex that could have tons of branching conditions inside of it. So how does regex figure out those branching conditions without being taken forever? And there's a bit of a trick to it. There's figuring out in linear time by doing something. I'd have to check on my notes, but I remember seeing this before and something else. Something. I don't remember exactly off the top of my head, but there was a trick to figuring out how to manage sort of like a branching thing. But yeah, we got through it. We got a pretty decent time yesterday. Slowed down by the second part as usual. Just some trying to figure out the best approach, I guess. It's not always immediately obvious to me, because I suppose a lot of these things I haven't really. It's like the first time seeing it, so I have to figure it out as I go along. But that's why I'm doing these things, is so I can become more familiar with a lot of these common, techniques. How to properly search through something, different common algorithms for certain things. How to manage, I guess, constraint programming in a procedural programming world. Yeah, hopefully we'll get another good time today. We have 4 more days left. Something like that. All right. Here we go. Day 20. Alright, high-speed train leaves the forest and quickly carries you south. You can even see the desert. After decoding, you discover that the data actually contains small images created by the satellite's camera array. The camera array consists of many cameras. Rather than produce a single square image, they produce many smaller square image tiles that need to be reassembled back into a larger image. Each camera in the camera array contains a single monochrome image tile with a random unique ID number. The tiles, your puzzle input, arrived in a random order. Worse yet, the camera array appears to be malfunctioning. Each image tile has been rotated and flipped to a random orientation. Oh, okay. Your first task is to reassemble the original image by orienting the tiles so they fit together. To show how the tiles should be reassembled, each tile's image data includes a border that should line up exactly with the adjacent tiles. Okay, all tiles have this border, and the border lines up exactly when the tiles are both oriented correctly. Tiles at the edge of the image also have this border. The outermost edges won't line up with any other tile. For example, suppose you have the following tiles. Yeah. By rotating, flipping, and rearranging them, you can find a square arrangement that causes all adjacent borders to line up. Okay. Now, when we're looking at this, do we have multiple borders that could possibly line up? It doesn't look like it. Are we saying that all borders only have one match? As far as I can tell, that does seem to be the case. I don't remember it saying anything to that effect, though. All tiles have this border, and the border lines up exactly when the tiles are both oriented correctly. Okay. So I guess we can first find a border image by saying this image has no adjacent on the left and no adjacent on the top. And then work our way through from there. Okay, so this is our puzzle input. Check that you've assembled the image correctly, multiply the IDs of 4 corner tiles together. All right, so let's get the test input first. Let's start figuring out how to parse this. So we have a bunch of things separated by a double new line. So we'll first say read all text, and then split this by a double new line. And then for each image and images, what do we want to do? We want to grab the ID from the first line. So ID equals image you want to, I guess, split this into lines too? First image line, what do we want to do? Let me say regex match this line, and our match will be tile E. Yeah, that should be good. Roots 1 value, and then parse this as an integer. All right, so from here, what do we want to turn this into? What would be easiest for us to recompose this? Maybe into 4 edges? And if we put it into edges, what would we do after that? The input said they have been rotated and flipped to a random orientation. Rotated and flipped. So that means, does that mean that the edge could be in any orientation? Rotated, flipped. Yeah, I think it means that it doesn't matter what their orientation is. So let's see, how do we... I know we can add the top and bottom pretty easily. That would be just image lines 1 and whatever the last one is. -1. And then to get the left and right, we'll do this. 4 equals 0. I guess we'll start at 1. I is less than image lines dot length -1. Or no. Yeah, like that. Let's see. Image lines I, and then 0 for the first character. And let's see. Line length will be image lines 1 dot length. Image line length -1. And then once we're done here, we'll say edges.add lefts, edges.add right, and then our I guess we'll have a dictionary of integers and a list of string, which will be our edges. I guess we'll call this tiles. Tiles.add ID and edges. Okay. Let's run that, see if we get anything that's coherent. All right, so images, no, we want tiles. So 2, 3, 2, 3, 11, which is this guy. So this is one edge, dot, dot, pound, pound, dot, pound, dot, dot, pound, dot. Correct. The next one is the bottom. This one should be left, right? So dot, bunch of hashes or pounds or whatever. Looks correct. Looks correct. Okay. So So I think I've got something there. Let's define this as our global. And then down here, we need to figure out the orientation. Oh, interesting. So our corners are going to be the ones with two that don't match. How are we going to match these up? And what was our input? Our input was a whole lot longer. So we need... Let's see, our tile is going to be the number of tiles divided by 3. Or, no, that's not right. The square root of the number of tiles. So we'll say our... Dang, how are we going to figure this out? I guess we can find the corners first. And then figure out the rest. Maybe find corners, which will have 2 edges that don't match. Or find the center first? Will our corners... Does it matter what orientation our corners are in? Yes, it does, because the top left and the bottom right, you could have 2 different orientations here. Well, let's add some extra functions in here. Let's see. We want something to match sides. Let's see. It should give us a match, right? And we can test that out with, let's see, 1951 and 2311. When I say 1951 and 2311, we get a true. All right. And how about 1951 and 1171? False. Okay. Is this going to be? All right. I guess we can find the corners first. And that's going to be tiles where I guess we also need one edge match count. Let's see. Tiles. Counts. Boy, that is a lot. Let's try that. Let's try that out first. Let's count the edges for 1951. We get 2. That's good to hear. Let's try 1427. We should get 4. We do. And one more. This one we should get 3. All right, it's working good. So our corners equals tiles where edge match count equals 2. So we get, ooh, we get 5. What is it saying that 2311, it was somehow included in here. 1951, 1489. $24.73, $29.71. Yeah, that doesn't make any sense. Hmm. $3.11. Let's try that one. This one says 2, so why are you saying that it's in this list? Count equals 4. $23.11. What is going on? Oh, it is giving me an incorrect answer. All right. Yeah, 2311 is giving me 2, but it should be giving me 3. So what am I saying here? Give me a tile and then count the edges that match any other tile where the key does not equal tile and any in the list. All right, let's do this instead. Tiles where key does not equal tile and where key dot value I guess it's just this. $23.11. Oh, you know, if you rotate them and flip them, then it would be backwards, right? Rotate, flip. Yeah. So not only does it need to match one way, so not only k equals d or k equals d dot reverse. Reverse and two string, that's gonna give me what I want, right? A, reverse, two string. E equals 2. No, we expected to get 3. Yeah, that's not how you do it. How do you reverse a string? Reverse a string. Oh boy. Let me just yank this function. Okay, we got 3 that time. All right. So one more time. Corners equals tiles where match counts equals 2. And we get 4, 1951, 1171, 2971, 3079s. All right, so we successfully got the corners. So we want to try the corners in each location. So that's going to be what is that going to be? Dang, this is hard. So we want to try the tiles in each corner. So you're going to have a total of what? 4? No. Something. You're going to have a bunch of different iterations of these 4 guys in 4 different corners. And then from there, we need to find... we can go one by one and find the matching ones. So let's first check. Let's first create a function and call this I don't know, check model. Create and check model. What are we going to say? So we're going to iterate through this image. I guess we can go, left to right. See. Let's see, if we're not on the far left, then we can, I don't know, check the one to the left. Or what do we want to do? We want to check, when we get to a corner, we want to check if the corner is valid. Hmm. How are we going to do this? Well, you know, we already found the corners. We don't really need to do the rest of this, do we? We just need the sum of the keys, right? 9172. Oh no, the product of the keys. How do we get the product? I think there's a trick here. It's like select mini or something. We'll just... what do we get? This big number? Yeah, so that's right. Alright, let's do it for this guy. Let's see if this number is correct. Yeah. Yeah, we wasted a ton of time. I only needed the corners. I didn't need to figure out the rest. Alright, now you're ready to check the image for sea monsters. The borders of each tile are not part of the actual image. Start by removing them. In the example above, the tiles become... whatever. Remove the gaps to find the actual image. Now you're ready to search for sea monsters. Because your image is monochrome, a sea monster will look like this. When looking for this pattern in the image, the spaces can be anything. Only the pounds need to match. Also, you might need to rotate or flip your image before it's oriented correctly to find the sea monster. In the above image, after flipping and rotating it, the appropriate orientation, there are two sea monsters. Determine how rough the waters are in the sea monster's habitat by counting the number of pounds that are not part of the sea monster. Oh, Okay. So we need to go back and actually solve this thing. So I guess we'll start and get the corners. And then what? Guess we'll need to stitch together the image somehow. And that somehow is an interesting question. So how about this? How about we try to figure out maybe we can stitch it together without worrying too much. Oh, dang. I mean, to figure this out, we need the original content. We need more than just tiles. Or more than just edges, I guess. Dang, how do we stitch this together? I guess we just need to start at one corner and start stitching it in from there. Well, maybe... Yeah, getting this far without figuring out the orientation and all that is not helping. I guess we could just put one image, one image on the top left and then figure out everything from there. And how did we add the edges? We added the edges top, bottom, left, and right. So we can basically say this. Renum sides, top, bottom, left, and right. Okay, so we can index into or maybe even I'll do that instead. And this guy, I think I want to get rid of. I want to get rid of conjoining lines, right? Well, I guess I could figure that out after I do the orientation. Oh, how would I figure out the orientation? Hmm. Okay, so we're going to have an array of all zeros, right? So we can set the first corner int 0, 0 to be equal to corner. No, image 0, 0 corner. And then from here, we'll go through one by one. What will we say? We'll set the one to the right and then set the one below and keep going until we can't, right? Let's see, if we're at the far right, size minus 1, continue. So if we're at the either the bottom or the far right, I guess we could just not go to the bottom if that's the case. No, if we're on the far right, we still want to check the bottom one. So if we're at the far right, no. All right, come on, brain. If we're not on the far right, then check the right. So we're just going to assume that the top left corner orientation is correct, and then reorient everything else to match it. Well, I guess we have to orient it properly, right? I guess we'll have a dictionary of orientations. All right, so we want the top left corner to have a top that doesn't match and a left that doesn't match. Oh boy, this is going to take me a long time. So I'm going to need to find the orientation of top left corner. Then I'm going to have to start going through one tile at a time to figure out the tile to the right and the tile below. And as I figure out the tile to the right and tile to the below, I need to figure out their orientations. Let's see, so I guess instead of orientations, I can just modify the tile list until it looks the way I want. So I can say rotate. I'll have a rotate function, and what it'll say is your sides. So we'll first add top, which will be the old left. Then we'll add bottom, which will be the old right. Then we'll add the left, which will be the old bottom. And then the top will be the old right. All right. We'll have another one called flip horizontally. So top will stay the same, bottom will stay the same, but we'll switch left and right. And then our last rotation is flip vertically. So bottom and top will flip. Left and right will stay the same. So how do we orient this in a way that will eventually get to the proper orientation? We'll need something like this. We'll need another edge match count, but this time we're going to check only one side. So count the tiles where wait, this doesn't make sense. What am I doing? We're going to say as match. And it's going to be tiles any where the tile is not the one we're checking, and d dot value any matches the side or matches the reverse of the side. Yeah, that's not gonna be exactly right. Because not only does it need to be oriented right, but the ones next to it are gonna need to have the proper edge. But I think once we figure out the corner, we can figure out everything else pretty easily. So maybe not reverse it? Hmm. I'm gonna have to figure out the orientation of the right and the bottom as well to figure out if the corner is correct. I guess we can rotate. Okay, first we can rotate it. So while the left no, what did we call that? As match? We want to rotate it until the left and the top don't match. So we'll say tiles corner equals rotate tiles corner. All right. And what did we have to do? Let's see. 1951. Let's get this into some notes. 1951 originally looked like this. And it eventually turned into this. So it was rotated? Rotated once? No. It was flipped. Yeah, all it was flipped. Oh, I see. So we can't really do this. Because we don't know. No, wait. Yeah, we can rotate it. Hmm. What am I doing? Let's say we were in some weird position. If we rotate and flip every time, will we eventually get to the right? No, we won't. We got to get it to a position where the left side doesn't match, the top side doesn't match. The right side matches, but it also matches only one with the top side that doesn't match. So we may, I guess, we can find our corner matches, which is going to be tiles where T does not equal corner and edges match D and corner. Now let's try that down here. What do we want to test? 1951? No. Alright, corner matches, I get to 2311 and 2729. Okay, so that's working at least. Now, maybe I could just flip it randomly. So let's rotate it and flip it. If toggle, we'll flip horizontally, else will flip vertically. And we want to check, we want to do this until the left side doesn't match, the right side doesn't match. And yes, it's not going to work if the tile to the right and the tile below don't properly match. Oh, you know, I don't think I'm flipping these properly anyway. If I rotated, I need to reverse these, right? Hmm. Oh boy. This is way too much to keep in my mind. There's got to be a simpler way to do this. I guess. Hmm. Yeah, maybe I shouldn't be doing this at all. I like the sides part to figure out what things match up with what. But what I probably should be doing. Yeah, how would you flip a 2D array? Hmm. I guess if I was going to do it as a 2D array, I need to have functions to flip and rotate. And then, yeah, I'm going to have to do that anyway to get the proper tile set. Then I'm going to need to extract sides. Yeah, this garbage is not going to be it. Probably should have thought about this a bit more before jumping too far in. So I need to represent these in a 2D array. That's step one. Then I need functions to flip and rotate. I need functions to extract the sides. And then match the sides. I mean, if you can flip and rotate, the sides can be in any orientation, right? No. Not any orientation. Two sides are always going to be next to each other. But I guess... Yeah, you're going to have two sides that are always oriented the same, sort of. I guess we don't need to worry too much about matching... Let's see, what do we need to do? Yeah, let's go ahead and delete this. Let's get our full tiles. Let's make it a two-D array. Once we get here, The line length. Or, yeah, this is supposed to be a character array, huh? Oh boy. Yeah, I could already tell it's gonna be a hard one, because it's a lot of stuff to keep in your mind. I don't know, cognitive load or whatever they say. So it's harder to reason about fairly simple things like, flipping and rotating if you're thinking like, oh, this is, a 2D array or this is a group of sides. Let's see, line. What is this called? Image lines. J and I. J being Y, I being X. All right. So we have full tiles as a dictionary of character arrays. So down here we have our method to figure out the corners. Once we get one corner, I guess we need functions again to flip and rotate. Now is do we only need one? Yeah, if we rotate, and we only need one flip and one rotate. So let's create one for let's call this, we'll have one for rotates. And I guess we need the size, right? New image equals new, again, this is a character array. Size, say cubic or whatever. And we'll say new image ij equals image 2D size minus j minus 1 in I. This should give us a rotated image. All right, let's clean this up slightly. All right, and we want to do one more for flipping. Just like this. Let's flip. And we will... I guess I could just flip it horizontally, right? One line at a time. Hmm. How do I flip this? Well, I guess I could just go in reverse, right? All right, so we have it as 2D array. We have the ability to flip vertically and horizontally. I guess we need the ability to grab a side as a string. Guess we didn't need to specify size up here. Let's see. Oh, this is insane. I'm gonna have a ton of steps after this still to complete. None of them are easy. There had to have been a simpler way to complete this. Hmm. Oh. Dang it. Let's see. If it's the top, then it's going to be I0. Going to be the bottom. It's going to be I. It's -1. Yeah, I'm getting like super far into a lot of functions that I'm not even testing. So there's a ton of stuff that could go wrong anyway down this long chain of things I'm doing. So let's see, if it's left, then I want to go from the bottom up. On the right, I can go from the top down. So it's size -1 and 0. But if it's on the left, I want to go from the bottom up. Or no, I still want to go from the top down, right? Because that's how I'm going to match two strings. Wait, let me think about that. Top down, top down. All right, so have the ability to flip, have the ability to get a side. So let's start by orienting a corner. So we'll get our matching sides like we did before, which would be tiles where lead is not equal corner, and any side matches Tiles where it's not our corner and the sides match any of ours. Oh. Oh, that's this right here. Come on, brain, you can do it. Alright, so we got our corners. We want to do the rotate thing, right? Will it matter if we're flipped or not? No, it shouldn't matter, should it? Oh, I gotta look at my dumb image thing again. I have a hard time visualizing this in my brain. All right, so it doesn't help. Hmm. Not. Oh, this is so dumb. I'm not thinking about this right. Well, how about we do this? How about we do just rotate it? Well, this one was flipped top to bottom. But it doesn't really matter, right? Because this could have been... This could have been over here. Okay, let's just assume it doesn't matter. What were our functions that we created? Edges match. I think has match is what we want. Let's see, get side. We want full tiles corner, and we want top. And left. We want to say rotate. And we'll get the top and left again. Let's all right, so back to stitching images. I guess let's just keep finding the match for the one on the right. Well, I guess if we're in the left column, we'll find our top matching image. I guess we'll want to we want something that'll orient us based on branch to top. I guess we first want to find the matching side. So we're matching to find match let's see. Tile bottom equals get side tiles tile and s dot side dot bottom. String tinge. Okay. And for tiles where d dot key does not equals tile and d dot value any match or e equals reverse tile bottom. All right, so we just need to return matching tile dot I guess we can orient at the same time while we're here. So matching tile top equals get side let's just assume there's one and only one. I guess we can throw an error here just in case. All right. What do we want? Tiles, key. No. Full tiles. M key. And we want the top. We're going to say while M key. Wait, what is... Oh. Well, matching tile top does not equal tile bottom. We want to flip and rotate until we get there. I guess we can rotate first by disregarding oh dang. What was our flip? Was our flip vertical or horizontal? We were flipping vertically. But in reality, I want to flip I guess on the top to bottom matches, I want to flip horizontally. This is flip vertical. Let's create another one for flip horizontal. Which is what am I, 2 hours in? Yeah, I'm gonna kill the stream. I'm certain this is gonna take me a very long time because I still have to do many additional steps across this. So I'm guessing this is gonna take me maybe probably another couple hours. So I'll end the stream because just because nobody needs to see this. But I guess so far what I'm doing is I'm gonna go through left to right, top to bottom. And when I get to I'm gonna create like a integer 2D array like this. So I'm gonna start here, go left to right, left to right, left to right. So when I get to 1, 0, x equals 1, y equals 0, I'm gonna say find the match to the one to your left, and then orientate yourself properly, then go to the next one. But when I get to this column, I need to find myself as a match to the one above, and then orientate myself properly. And then ideally, once I get to the end, I'll have all the orientations that'll look like this. It'll say like 1951 and so on. And all of my tiles will be orientated properly. So after that, I'll have to stitch it all together by getting rid of the matching sides. So basically, if I'm, on the top, I'll get rid of the left and right, so on, until I get one cohesive image. And then from that, I'll need to figure out this part where I need to search for this pattern. And if it's in there, then I subtract those matches. Where was the sea monster in this one? Oh, so they had to rotate it. Where did they rotate it? They rotated it and then flipped it horizontally. And then it's like somewhere in there. Okay. That'll be a challenge. I wonder how I'll match that. Well, I gotta get to the stitching part first. And yeah, that's gonna take me a while. So that's it for this stream. Just imagine that I solved this 5 minutes before I ended the stream.